Good morning, sir. This is Tanusha from CSC department from first year. Today topic presentation is free anionic mechanism of PVC. In this slide we have outline of the presentation. Introduction to anionic polymerization, characteristics of anionic polymerization, structure and reactivity of vinyl chloride, role and types of initiators, initiation nucleophilic attack, formation of active carbanion, propagation mechanism, propagation kinetics and rate factors, termination pathways, side reactions in anionic PVC mechanism, final PVC structure, properties of resulting PVC, industrial considerations, and loss fun advantages and limitations of anionic PVC mechanism. In this slide, we have introduction to anionic polymerization, a chain growth polymerization mechanism involving anionic species, and it requires strong nucleophilic and strict execution of moisture and impurities. In this slide, we have characteristics of anionic polymerization. Fast reaction rates leaving polymerization minimal termination, and it is the ability to form block copolymers. In this slide, we have structure and reactivity of vinyl chloride. CH211CHCl structure enables nucleophilic attack, and the chlorine atom creates polar influence enhancing anionic reactivity. Electron withdrawing effect stabilizes carbanion. In this slide, we have role and types of initiators. Common initiators: alkali metals, NH2, organometallic compounds. Strong nucleophiles are essential for reaction initiation. Initiator selection impacts polymer architecture. In this slide, we have initiation nucleophilic attack. Initiator attacks beta carbon of vinyl chloride. Bond rearrangement creates carbanionic spaces. Initiation efficiency determines polymer uniformity. In this slide, we have formation of active carbanion and propagation mechanism. In formation of active carbanion, carbanium stabilizes governs propagation speed, and chlorine substituent increases stability via inductivity effect, and solvent polarity also influence intermediate stability. In this slide, we have propagation of mechanism. Carbanions and adds monomers sequentially results in rapid chain growth until termination. Considered a living mechanism under ideal conditions. And in this slide, we have propagation kinetics and rate factors affected by solvent temperature, monomer concentration. In higher temperature, increases reaction rate but may destabilizes carbanions, and purity of monomers crucially for avoiding premature termination. In this slide, we have termination pathways and side reactions in anionic PVC mechanism. In termination pathways, typically terminated by proton donors, traces of water or alcohols. Impurities can quench reactivity carbanions, less common that in radical polymerization. In side reaction in anionic PVC mechanism, beta elimination for polyenes chain transfer reaction, uncontrolled sign reaction may cause decoloration. In this slide, we have final PVC structure and properties of resulting PVC. The final PVC structure is a linear chain with alternating carbon backbone and pendant CI groups. Structure determines physical and mechanical properties. In properties of resulting PVC, high rigidity due to CI substituents and good chemical resistance and durability, and susceptibility to thermal degradation without stabilizers. And in this slide, we have industrial consideration. Anionic route requires extremely pure conditions. Industrial PVC typically produced via radical polymerization. Anionic methods explored for specialty PVC applications. In this slide, we have advantages and limitations of PVC anionic PVC mechanism. Advantages: uncontrolled molecular weight, low polydispersity, and limitations are sensitive to impurities, not widely industrialized, and higher cost due to process constraints. And thank you. Presentation by Tanusha from CS department, first year.